Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
The topic for today's lecture is going to be few numericals based on three-phase voltage, or three-phase circuit. Let us see what is our first numerical. Now the first numerical says that three similar coils, each of resistance 8 ohms and inductance of 0.02 Henry. Okay, so what we will do is we will write the given values first. They are connected in star. So we know that they are connected in star. Then the load is resistance and inductance. Correct? Three phase of 230 volts and 50 hertz. Okay. So what all is given? First of all, the load is given, which is the phase resistance 8 ohms. Then it says inductance of 0.02, so 0.02 Henry. Fine. Then 230 volts 50 hertz, so frequency is 50 hertz. Then 230 volts. Now what is this 230 volts in case of three phase voltage? This is the line voltage. Okay, this 230 volts, whatever will be specified, that is the line voltage. Fine. Now we will be required to calculate the impedance in this case. Why impedance? Because the load consists of an inductor and a resistor. So this is ZPH, that is a phase load. R and L. R is 8 ohms and L is 0.02 Henry. Fine. So first we have to find out what is Z. ZPH. In order to find out ZPH, first we will have to calculate XL. Fine. Okay. So we know how to calculate XL, isn't it? So how to calculate XL? XL is omega L, which is 2 pi FL. So we shall place all the values. So 2 into 3.14 into 50 into 0.02. So our XL comes out to be 6.28 ohms. Fine. So let us write the load which is connected at the phase. So this load, since it is a series combination of resistance and an inductance, the load will be R plus J XL. Fine. So my load will be R. R is 8 plus J. Okay. XL is 6.28. This will be in ohms. So this is Z. Fine. Okay. Now see, this is a star connection. Okay. This is a star connection. Fine. In star connection, the relationship between the line voltage is root 3 times phase voltage. Okay, this we have already seen. So therefore line voltage is given. So what will be the phase voltage? It will be the line voltage divided by root 3. Okay, so what is the line voltage? 230 volts divided by root 3. So the phase voltage after dividing 230 by root 3 comes out to be 132.79 volts. Fine. So I got my phase voltage. I have my I have my impedance. So what should be the next step? I can very well calculate current. Which current? Phase current. So phase current will be phase voltage upon phase impedance, right? Correct? Now, when you talk about impedance, what was the impedance? 8 plus J 6.28. Correct? But this is in rectangular form. If I have to divide this ZPH, then I have to convert it into polar form. I have already discussed how to convert rectangular into polar. So after converting this into polar form, the value comes out to be 10.17, the magnitude, and the angle comes out to be 31.13 ohms. Fine. So here the magnitude of Z is 10.17 ohms and the value of phi comes out to be 38.13. Okay? Yes. So now I shall be putting the value. Now what was my phase voltage? It was 132.79. And what will be ZPH? Now I have to take the magnitude. What is the magnitude? 10.17. So my phase current comes out to be, after dividing 132.79 by 10.17, the answer comes out to be 13.06 amperes. Fine. So this is the phase current. But in star connection, this is same as line current. Correct? So I found out the line current also. Okay? Yes. So let us go back to the previous slide. Yes. So they said calculate line current, total power absorbed, reactive volt ampere and total volt ampere. Fine. Okay. So I shall erase this first. Now line current, phase voltage, everything has been found out. Now we need to talk about power. So what is the total power in three phase? The total power is given by √3 VL IL cos phi. This is the value, correct? This is the equation. Now we know all the values. So √3 into, what is the line voltage? 230 volts. What was the line current? 13.06 amperes. And the value of phi was 38.13. So cos 38.13 degrees. So now the total power comes out to be 4092 watts, which is nothing but 4.092 kilowatt. So this is the answer. This is the power. But remember, this is P. P means active power. Active or real power. Now we need to find out reactive power, which is also represented by volt ampere. And it is represented by Q. How do we write the equation for it? √3 VL IL. Instead of cos phi, we have sin phi. So it would be, Q will be √3 into 230 into 13.06 into sin 38.13. So Q comes out to be, after calculating this, I got the value to be 3210 VA. The ampere for Q is not watt. Please remember this. It is volt ampere. Now this can be converted into kVA, correct? Rather kVAR. One second. This is Q, right? Yes. So it is not VA. It is VAR. Yes. So same can be converted into kilo. So it becomes 3.210. Okay. Fine. Now again we have to find out the total volt ampere. Total volt ampere, which is represented by S. Now there are two ways by which we can calculate S. Okay. One is S is equal to root 3 VL into IL. This is one way. Another way can be S is equal to square root P square plus Q square, because S is the total power, which is the resultant power of P and Q, resultant of P and Q. Fine. So let us calculate it by both the ways. So S becomes root 3 into 230 into 13.06. So S comes out to be 5.2 kVA. The next method is you can directly calculate S by using this. Okay. So P was 4092 square. Q was 3210 square. So the value of these after adding it and when we take the square root of this large number, it comes out to be 5200 VA, or S comes out to be 5.2 kVA. So whichever way you prefer, you can calculate it. Fine. So this is it. So simply we have to make use of the equations which we have already derived, and then we will be able to calculate all the things. Okay. Let us go to the next numerical. The next statement says 3 identical coils, each having resistance of 15 ohms and inductance of 0.03 Henry, are connected in delta across 3-phase 50 Hz 230 volt supply. Again we have to calculate phase current, total power, but here one additional thing has been asked, and that is we have to draw the phasor diagram. Okay. And in the last numerical it was star connection, whereas in this numerical it is delta connection. So let us note down all important things. So first of all, the connection is delta connection. Okay. Fine. Now in delta connection, we know line voltage is same as phase voltage, so which is 230 volts. But in delta connection, the line current is not same as phase current. It is given by line current is equal to root 3 times phase current. Okay. What else is given? Resistance is given, RPH, which is phase resistance, 15 ohms, and L is given 0.03 Henry. Okay. So first we shall find out what is XL. XL is 2 pi FL. So we shall be placing the values 2 into 3.14 into 50 into 0.03. Fine. So XL comes out to be 9.42 ohms. Okay. So what will be my impedance now? Resistance of 15 ohms and inductance of 0.03 Henry. Okay, so they are connected. So the total impedance becomes R plus JXL. I'm sorry. Yes. R is 15 and J is 9.42. Again, this is in rectangular form, so I need to convert it into polar form, and after converting it to polar form, the value is, the magnitude comes out to be 17.71 and the angle becomes 32.13. Okay, so this angle is nothing but phi. Okay. So what is the next step? I have to find out phase current. What is phase current here? That needs to be calculated. The phase voltage upon, this was ZPH. Yes. So phase current was the phase voltage upon the phase impedance. What is phase voltage? In delta connection, phase voltage is same as line voltage. So it is 230, and we have to take the magnitude of ZPH and that in polar form, so it is 17.71. So the phase current comes out to be 12.99 amperes. This is phase current. This is one answer. Okay? Yes. What is the next step? We will be calculating the line current now. Now what is the equation for line current? Root 3 times phase current. So root 3 into 12.99. So my line current comes out to be 22.5 amperes. This is one more answer. Okay. Then I have been asked to calculate the power. That is the total power. The total power in three-phase circuit would be root 3 VL IL cos phi. That is P. Correct? So it would be root 3 230 22.5 into cos. What was the value of phi? It was 32.13. Okay. So this power, which is the active power, comes out to be 7.59 kW. Okay. So we are not asked to calculate anything else. Now we have to draw the phasor diagram. Fine. So what all will be required to draw the phasor diagram? First we have to have the value of phase voltage. What was phase voltage? Since it is delta connection, it is same as line voltage, so 230 volts. Then I'll be I want phase current also. So that was 12.99 amperes. Okay. Then I would require phi. So it was 32.13 degrees. And then the line voltage. Okay. That was 22.5 amperes. So these values are required. Okay. Fine. So the first thing is we have to draw the first phase voltage. So first we can take any reference. Okay, we can take any reference point. Generally it is taken to be in x-axis. Fine. So I would assume it to be phase 1 voltage. Now I know that all other voltages are 120 degree out of phase with this, correct? So this is 120 degree and somewhere here is again 120 degree, correct? And it moves in anticlockwise direction. So this is phase voltage 2 and this is phase voltage 3. Fine. So we have represented it. Okay. Now what was the load? Load was resistance and inductance. Had it been only inductance, I would have drawn the current which is 90 degree lagging to the voltage, but it is resistance plus current. So this load will have the phase difference which is smaller than 90 degree, but it will lag behind the voltage. Correct? And remember that all these currents will be equal in magnitude. Correct? Even the phase voltages are equal in magnitude. Fine? So what I will do is, I will draw phase current which is lagging. So this is phase current 1 and this angle is nothing but phi. Similarly, I will draw one more phase current which is lagging. So this is phase current 2. Correct? And similarly, I will have phase current 3. And remember that all these are phi because they will have equal phase shift. Okay? Done? The next point is line voltage. Now, what is line voltage in delta connection? It is same. So, it will be, if I wish to draw line voltage, then I have to override the phase voltage. So, what I can write is, I will tell them that in delta connection, phase voltage is same as line voltage. Okay. Next is line current. So, in delta connection, what is the phase difference between line voltage and, line current and phase current? What is the phase angle between line current and phase current? The line current lags phase current by 30 degrees. Okay, we have seen this. So line current lags phase current by 30 degrees. Okay, and secondly, see this equation. Line current is root 3 times phase current. It means line current will be, the magnitude of line current will be more than the phase current magnitude. Fine. So now I will be drawing the line current. So line current will be lagging. Okay. And it will have more amplitude. So this is line current 1 and this phase angle is 30 degrees. Similarly, somewhere here is line current 2. Again, this angle is 30. Similarly, here again I will have line current 3. And this angle is also 30 degrees. So that's all. This was the phasor diagram for this question. Please remember that whenever phasor diagrams are drawn, not only the phasor, that is the angle, is important, but the same amount of importance is given to magnitude also. So when you draw the phase voltages, remember in balance system, the magnitude of all phase voltages are same. The magnitude of all phase currents are equal. The magnitude of all line currents are equal. Okay. And in delta connection, line current is greater than phase current. So that line should be bigger. When you draw line current, it has to be bigger than the phase current. You cannot draw them equal, or you just cannot take the length of that line to anything what you wish. You know, we cannot take it as per our wish. There is some relation. Fine. So with this numerical, we end today's class. Thank you.